So we talked about how to find the horizontal asymptote if the degree of the denominator is bigger than the degree of the numerator. But what happens if the degrees of the numerator and denominator are the same, or if the numerator's degree is greater than the denominator? So we're actually going to answer that first question right now. And as it says here, that second question there, when the degree of the numerator is bigger than the denominator, we will do that in the next lesson. So today's lesson, let's focus on when the degrees are the same. So here is a rational function where the degree of the numerator and denominator are the same. They're both 1. And they want you to find the horizontal asymptote. So it looks like it's going through y equals 1. And that kind of checks out. When you look down here, this fraction is getting closer and closer to equaling 1. And that's kind of interesting that that's happening. In fact, that's kind of cool. It's because up here we have x plus 3, and here we have x minus 2. Well, adding 3 to a really, really, really big number isn't going to change it a whole lot. And subtracting 2 from a really, really, really big number isn't going to change it a whole lot either. And so basically, whatever you're putting in for x, even though you're adding 3 to it on the top and you're subtracting 2 from it on the bottom, the bigger x is, the less of a difference that's going to make. And the top and bottom will be almost the same thing. And you can imagine with a really, really big x, this is going to be essentially 1, right? And so if you go out to like a million, billion, trillion, it's going to be almost 1, off by just a little tiny bit. So this should remind you of the end behavior lesson we had back in the polynomial chapter, where it turns out the first term is the only term that really matters when we're looking at a polynomial in extremely large and extremely small values. Let's see how this changes if we change our polynomial. So here's another one where we have 2x plus 3 on top and x minus 2 on bottom. Now the degree of both of these is 1, okay, but the coefficient here is now a 2. And keep in mind that this plus 3 and this minus 2, they're not really doing a whole lot when you get big x's. So if we ignore these, you get basically this fraction here, which is going to equal 2. And as x gets bigger and bigger and bigger, it gets closer and closer to 2 because this plus 3 and minus 2 are having less of an effect on it. And so the top number is going to be twice as big, essentially, as the bottom number. And so the ratio here is going to be closer and closer to y equals 2. And here it's kind of funny, you can play with this and move this around to different levels. Let's make it an asymptote at y equals 5. And the equation for that would be 5x plus 3 over x minus 2. And if you ignore the 3 and the 2, 5x over x is basically just going to be 5 times bigger on top. And so for really big x values, you're going to get a fraction that is close to being 5. So what we're doing is looking at this fraction and what its behavior is going to be like for big x's, which means we can ignore this stuff and just basically look at this part of the ratio. And obviously that's equal to 5 if you cancel out the x's. So here we have two polynomials where their degree is also 1, okay? And this time the leading coefficient is a 4 and a 2. Okay, so what do we think is going to happen with this one in the long run? So looking at our graph over here, it looks like it's y equals 2 for our asymptote. And down here in our table, it looks like it's getting closer and closer to 2 as x gets bigger and bigger and bigger. So our asymptote is y equals 2. Okay, now how can we get that? By looking at the equation. Well, if we ignore the stuff that's not going to matter when x gets really, really big and look at just the leading terms, we get 4x over 2x, which is essentially 2. And so this horizontal asymptote of y equals 2 makes sense. When x gets really big, this fraction is going to get closer and closer to the ratio of 4x over 2x, which is just equal to 2 when you simplify it. So to summarize, when the degree of the numerator and the degree of the denominator are equal to each other, then you can determine the horizontal asymptote by just looking at the first terms and what the ratio between them is. So here you got 5x over 2x, so that's going to be a ratio of 5 over 2. And so my horizontal asymptote will be the line y equals 5 over 2, or y equals 2.5. Okay, and you can see that down here. Here we have the actual function that we're graphing, 5x plus 3 over 2x minus 2, and you can see its ratios. Okay, and then here it is without the 3 and the 2 being added and subtracted, and its ratio is 2.5. And like we said, when x is big, these numbers won't really matter.